Good morning, colleagues here in Brussels in the square and also online. My name is Guy van den Ede. I'm the Acting Director for Health, Consumers and Reference Materials of the Joint Research Centre, and it's my pleasure to welcome you to the One Health, Environment and Society conference, and in particular to the thematic session on augmenting human minds, artificial intelligence and big data in risk assessment. Now, to give you a first introduction to the thematic session of today, risk assessment, as we know, has reached its limit in the ability to be executed in a timely manner. First of all, it is very difficult to recruit relevant experts, and they are flooded with information that goes beyond their physical capacity to identify, to search, to read, to appraise, and to integrate the exponentially growing amount of data in a structured way. Automation of the process is therefore very much demanded, and artificial intelligence is anticipated to play an increasing key role in future risk assessment, and this on two different levels. First of all, to identify and mine the available data for the advancement of the risk assessment, but also to execute parts of the risk assessment. Now, the session today will explore the role that artificial intelligence can play in the conduct of future risk assessment analysis of big data, what challenges there are for the implementation, and how this may be entailed into a regulatory context. Now, the main objectives of the session of this morning are fivefold. First of all, we want to explore whether human expertise needed in risk assessment can in fact be replaced by artificial intelligence, either partially or fully. Secondly, we want to discuss which part of risk assessment processes are open to automation and which part maybe not. The third point is to identify which risk assessment related processes will continue to require human expertise. We will also explore whether future risk assessment will follow a human-augmented approach in which humans and artificial intelligence operate together in complementarity. And lastly, we would like to make recommendations on how to develop trustworthy artificial intelligence systems for regulatory science. Now, one of the expected outcomes from the organization's point of view is to have some take-home messages, to deliver in the regulatory domain to adopt or how to adopt the artificial intelligence, what is needed to keep us up with the world's technological agenda and latest innovation, both within Europe and outside. And therefore, discussions to follow on how artificial intelligence can be applied and how risk assessment process tools should adapt are to be provided. Now, before we start with the session, I would like to explain you a few things. First of all, there will be two keynote speakers that will address different sides of the coin. One will be on the opportunities, and the other one will be on the challenges of adopting artificial intelligence and using big data in risk assessment. Make sure to explain, I would like to explain that there is only a single question and answer session after the two keynote sessions, but I encourage you to log in to the event app and to start feeding in your questions. Now, if you're going to ask a question to a specific speaker, I would like you to mention the name of that speaker and then to provide the question that you would like to raise. It's also important that if there is a question that is already posted in the app that you like, you can actually let that know within the app so that the question becomes more prominent and that it will be most likely that we will address that question to one of the keynote speakers. The speakers obviously will do whatever they can to address all your questions, so be as sharp as possible in formulating them. And actually you can start already in posting your questions as from now and while the keynote speakers are talking. Now, without any further ado, I would like to welcome my co-moderator of this morning, Ilaria Del Seppia from the European Medicines Agency. Ilaria, the floor is yours.
So, thank you very much, Guy, and good morning to all of you. It's a great pleasure for me to open the session to explore artificial intelligence in big data and risk assessment today. As stressed yesterday from the Commissioner Stella Kyriakides, the pandemic has been the catalyst for the European Commission to invest in building a strong European health union for all the European countries to prepare and respond together to health crisis. Now, responding to health threat involve a number of elements, which are early detection of the threat through efficient surveillance and early warning system across Europe, but of course a competent risk assessment. The advancement on artificial intelligence have created positive expectations that many of these processes can be automated, gaining efficiency and effectiveness. And we are here today to explore further these expectations. So these advancements are also possible thanks to availability of large amount of data, which is also an expectation as envisaged from the European Commission flagship, the European Health Data Space, which will provide additional opportunity to harvest new health data for risk assessment. But this is also opening the need for defining new methodology to use artificial intelligence in an ethical way, and also for enabling regulators to accept the resulting evidences when taking decisions for public health. Now, at the European Medicines Agency already in 2020, the head of Medicines Agency and the EMA Big Data Task Force sets the vision that integrating big data in the benefit risk assessment and decision-making can support the development of innovative, safe, and effective treatments, and more quickly. So this vision remains central at our work at the agency and is also reflected in the newly published European Veterinary Big Data Strategy that was released last week. So can artificial intelligence leverage the new available data to more rapidly identify safety risks on medicines? Or can AI anticipate health threats due to antimicrobial resistance and drive innovative treatments development? And can toxicological data be reliably harvested through machine learning solution to power risk assessment? So these are the questions that we ask ourselves within the medicines regulatory network, and that we expect to essentially answer with the framework that is created by the EU VET Big Data Strategy, and also to shift the focus from a data collection to a data connection approach. So this strategy is also a reflection on of a very exciting time in that we are living within the European institutions, where a number of cross-agency activities are ongoing to define new policies, for instance, in the context of the new pharmaceutical strategy, but also in the remit of the chemical strategy for sustainability and the one substance, one assessment, for instance. Now, in this experience, the keywords are data reuse, data sharing, information dissemination that should be achieved by increasing interoperability of our system. And the overall ambition is to reduce administrative burden, to enhance consistency, transparency, and responsiveness across EU institutions. So clearly, we have a one-in-a-lifetime opportunity to see how artificial intelligence could enable these ambitions. So finally, of course, the ability to exploit artificial intelligence benefits passes not only through accessing and connecting data, but also connecting people and establishing cooperation forum, as stressed yesterday by the EFSA Executive Director. And I hope this session today will provide you with an opportunity for all of you to be inspired on the use of artificial intelligence to support risk assessment, but also to build connection and coalition of willings. And I welcome, for this reason, all the stakeholders today to augment your minds, think out of the box, and voice your ambition and experience in the use of digital technology to power future risk assessment. So with this, I think we can really start the session. And talking of voicing of view, I would like to launch the first polling station which is accessible via your app. So if you can express what is your view and what is the best statement that reflect your view on the usage of big data and adoption of artificial intelligence in risk assessment. And the answer that are presented through the apps are, so the first one is artificial intelligence and humans will seamlessly cooperate in future risk assessment. The second question is artificial intelligence and big data are great opportunity to make faster and more accurate risk assessment and generally improve outcomes in regulatory science. Then the third one is artificial intelligence technology and big data availability will never be enough to perform reliably and trustworthy risk assessment. And finally, if you think that artificial intelligence and risk assessment creates a liability and make risk assessment untrustworthy, big data cannot improve risk assessment because it is inherently prone to biases. Please select the last answer. So, I'm waiting for the result of the vote. Which are not displayed very. I think one of the key points is also information dissemination. And this is clearly not quite visible in the. So what we can see from these, at least I see this, only the last two votes. So the second option seems to be the one more popular. So we have an 83%. Okay, so we have an average of 80% of stakeholders connected today that believe that artificial intelligence and big data are great opportunities to make faster and more accurate risk assessment and generally improve outcomes in regulatory science. So the expectations on artificial intelligence, as I said, is very great these days. And I think we can start the session on these very ambitious results. And with this, and without any further ado, I would like to introduce you with the first speaker, Dr. Hans Marvin. Hans Marvin is a senior specialist from the Wageningen Food Safety Research and brings wealth of experience in various aspects related to food safety, including analysis of food, research and, on safety and risk assessment, also carried out for EU public institutions and also in the Netherlands. So Dr. Marvin today will provide an insight and deep dive on the opportunities of big data and artificial intelligence in food safety risk assessment. So welcome, Dr. Marvin, for his keynotes. The stage is yours.
I'm waiting for it. Okay, yes. Thank you very much, ladies and gentlemen, chairman, chairwoman. First of all, I would like to thank the organizers for giving me the opportunity to share with you some recent examples on how big data and artificial intelligence can support the food safety risk assessment. My name is Hans Marvin, and I work in Wageningen Food Safety Research, which is part of Wageningen University and Research located in Wageningen, the Netherlands. The outline of my presentation is as following. First, I would like to address big data briefly, what it is, and then I will explain in more detail how big data and artificial intelligence can support the implementation of a system approach in food safety risk assessment. Following, I will present some distinct examples of new application of AI in food safety, and finally I will end with some conclusions. When we dive into the literature of big data, you will find many different definitions. One of them is provided by the European Commission and is shown on this slide. And I think it covers well the big data technologies and is widely accepted. It says that big data refers to a large amount of different types of data produced with high velocity from a high number of various types of sources. Handling today's highly variable and real-time data sets require new tools, methods such as powerful processors, software, and algorithms. This is a very nice definition. In short, it means when your traditional methodologies cannot cope with your data anymore, then you most probably are dealing with big data. About 7-8 years ago, because big data was much in the media, we thought we should search the scientific literature for examples of application of big data in food safety, because that is our domain. Very few examples were found at that time. Some years later, we repeated the same study, and these results are published in the journal Current Opinion in Food Science, which is shown here in 2020. So if you are interested to read more about the applications in food safety, I refer to this paper. In this study, promising developments were shown in the application of AI, but they were apparent and they were increasing compared to the first study, but it is generally it was in its infancy when you compare it to the application of big data in other domains, such as the medical sector. Promising developments were shown in the application of AI to support the implementation of system approach in food safety analysis, and I would like to show you in a couple of slides in more detail what that entails. It is nowadays well recognized that a web of mutually interacting drivers of change from many different domains, such as geopolitics, technology, environment, health, have a direct and indirect impact on the performance of a food supply chain. Such web of interactions are complex and not well understood. It is generally accepted that a system approach is needed to address the current problems and to enable the development of a truly sustainable food production and food security. Unfortunately, traditional methodologies have not been able to support the implementation of such holistic system approach. We have investigated how artificial intelligence can help us to implement a system approach in the prediction of food safety risks. When addressing these challenges, we need a technology that could handle the following characteristics, as shown on this slide. First, we need a technology that could integrate data from many different drivers, expert knowledge, and also information organization of food supply chains. Besides that, it should be able to integrate expert knowledge and data. It should be able to handle huge amount of data and knowledge gaps, use a variety of data sources of diverse nature, and preferably, because that was also one of our research needs, it should be able to allow scenario analysis and to study mitigation actions. And our question was then, can big data help us? After an intensive search, specifically in other domains than food safety, because it was not present there. In medical sector, we found that Bayes' network fit into these characteristics. And I have a couple of slides showing how that works. The Bayes' network approach that we set up consists of the following steps. First, the identification of the drivers of change, the factors that influences in a holistic way your problem. The factors are identified either or generally together with a literature search combined with expert consultation, and that can be many different types of expert consultations. It depends on the problem, which is the best consultation that you have to apply. Then it follows the data collection, and then the most easiest steps is the model development and the validation. A typical example how such Bayesian network looks like and the type of data that can be integrated is shown here for a Bayesian network on food fraud that we have developed. Here, the Bayesian network integrates 36 different drivers, 80 of which 80 were data sources and 8 expert judgments. Following such approach that we have set up step by step, by the way, we have applied this in many different cases, not only on food safety. And this slide shows you a couple of Bayesian network that we have developed for predicting contamination in foods, in products like fruit and vegetables, the milk, salmon, spices, herbs, and also in food fraud, which I just showed you in the previous slide. We also use the same principle to predict the safety of nanoparticles based on the structure of nanoparticles. But also together with colleagues in Wageningen, we predicted with Bayesian network the yield of potato, which outperformed the current mechanistic models they had at hand. And also another example is we predict the classical swine fever and avian influenza in poultry. And finally also contamination in shellfish. So all of these models generally had an accuracy about, let's say, over 90% accuracy, which is very good. And generally, we also test other algorithm, whether they perform better or worse, just in order to check which one is the best performing. So this approach seems to be applicable in many different research questions, so not only food safety. And we do believe that such methodology may also help to implement the One Health approach, the topic of this conference. So it most probably can be implemented wider. This slide shows you that Bayesian network of food fraud, that we also can automate the collection of the data. Here all the data from the different data sources of the Bayesian network were automatically visited, the data extracted that we needed, processed, inserted into the Bayesian network, and then visualized in a dashboard like this for the operator so that he online can have real-time information to make the, let's say, expert judgments. Artificial-based models often perform much better when more data is, can be used, and one of the examples that we showed is the Bayesian network. So the more data you have, the better they become. In the food supply chain, data is collected by many different actors, the farmers, the industries, authorities, and sharing that data is very difficult. So there's big challenges there. A very new approach that we found in the medical domain is the fair learning or the fair data train approach. We have made an animation to show it, and that will follow now for the next 2 minutes.
When it comes to the food we consume every day, we want it to be safe. We all benefit from detecting food safety problems as early as possible. Food safety prediction models can do that. But these prediction models need data from all stakeholders in the food supply chain, such as authorities, farmers, and food companies. Today, this data is not easily shared because data is considered sensitive, and data protection should comply to regulations like the GDPR privacy regulation. The Food Safety Data Train concept solves this problem. It is designed to make data from different stakeholders accessible with maximum data protection. The data of each stakeholder is linked to a secure data station, like a railway station. These data stations are connected via a secured infrastructure, like a railway network. And like trains, validated prediction models travel towards the data stations. Here, the data can be used. The prediction model can train itself and become smarter, while the data never leaves the data station. Data station owners can control which prediction models can access the data station and for what purpose. In return, the data station owners can benefit from smart food safety prediction models, or they might receive a compensation. In this way, data becomes available for food safety control purposes with maximum data protection, ultimately improving food safety for us all. Learn more about our work? Visit www.wer.eu/bigdata-foodsafety.
Using this concept, we successfully developed a prototype for food fraud in which 3 data stations on different geographic locations were connected, and a Bayesian network was learned from the data from these different stations without the data leaving the data station or the database of the data owner. So the concept worked very well, and we have high expectation for future implementation of this approach. The next couple of slides will show you some examples of the application of AI in different aspects of food safety. And here the first one shows you a text mining-based AI approach to collect media reports on food safety topics using the European Media Monitor infrastructure. In this way, we have demonstrated that the system can also be used for early warning, and that you can find new compounds that you were not aware of. Another way artificial intelligence can be useful for a risk assessor is here. This slide shows you that a word embedding technology can be used to search a huge amount of scientific literature. In this case, it's about more than 2 million abstracts and titles for new compounds or things that you don't know about. And here we could find 10 new stimulants that were not known for by the experts on this topic in our institute. In food safety risk assessment, often a systematic literature review is conducted to obtain an overview on the state of the art of a specific topic. For example, the big data that I showed you that we did recently. This is a very time-consuming process. And text mining and machine learning technologies can be used here to mimic the experts doing the selection of relevant papers. And that saves a lot of time. At the end, you have to do some reading. This slide shows an example in which we have developed a dashboard showing newly published paper of a specific topic that were automatically selected and collected from scientific literature database, in this case, PMC. The green bar, and I will try to highlight it here, so these are the different studies of which a systematic literature review have been done in the past. They were based on the green articles, and we automatically collect the ones that are relevant for this study, and these are the blue ones, and they are stored and visualized in this dashboard, and you can download it in an EndNote. And when the blue bar is really big compared to the green one, that might trigger you and say, okay, maybe now it is time to do a literature review over again, because so much new literature has appeared. So the last couple of years, also in our institute, we have observed increase in the development of on-site online devices to measure food safety hazards. Different technologies are on the market, such as spectroscopic devices based on Raman-Near, smartphone-based immunoassays, portal MS even, and even more. And this trend is increasing and increasing. So collecting of food safety hazards becomes easier and easier and is done on site. But also other data sources can be used to predict food safety hazards. And here's an example where we used satellite images and deep learning and neural networks to connect it to mycotoxins, pesticides, and other hazards that are on a grass or maize field. The efficiencies, though, were not that high, so the accuracy, so we need to improve this methodology. Another example here is the use of smartphones, taking picture of in this case, milk powder, and with deep learning models, you can predict the content of melamine. And another, more or less a similar principle, here you take pictures of meat, still in its package, and with the models you can predict the contamination of bacterials. Finally, I come to my conclusions. Big data in food safety is not yet fully applied. We did not find real examples of high volumes and velocity, but applications dealing with high variety and veracity was indeed found. We expect that future trends on smartphones, such as online and on-site analysis, blockchain, using social media for food safety identification, will further stimulate the big data technology implementation. A system approach in food safety and automated data retrieval and processing is being developed. Results are encouraging, and we expect it will continue being explored in the future. Finally, big data infrastructure and acceptable data governance methodology are really needed, and maybe that federated learning can support this and overcome these problems. I hope with this overview I have given to you, which is just a snapshot, has given you some flavor of what AI and big data can do, and maybe you will do it in the future as well. Some recommended further readings are shown in this slide, and I have just enough time, 1 minute, to acknowledge all the colleagues that have worked on this research, which is Jan-Min Boesenbrak, Ninjing Liu, Anand Gavai, Wouter Hoenderdaal, Leonieke van den Bulk, Lucas van de Heuvel, Wenjan Mu, Neris Ozen, Gianluca Frasco, and Kanju Jin. Thank you very much.
Thank you very much, Hans, and please have a seat. Many questions already come to my mind, and I'm sure also to the audience mind. And I see that some questions are already being posted, so please continue to post your questions. We will deal with them at the end of the session. And also please continue to like certain questions because those then will be asked with priority to our speakers. Let me now introduce our second speaker of this morning, Raluca Crisan. She has a vast experience in data science, working with a variety of clients, and she's co-founder of Etiq, which is an observability platform which supports the entire artificial intelligence machine learning lifecycle. Her talk will be on watching the watchman, testing AI systems intended for risk. Please, the floor is yours.
Hello, thank you so much for having me here, and thank you for the kind words in the intro. So yeah, I'm very excited. Once I figure out how to use this, I'm very excited to be talking about, how to test and the potential risks that machine learning and artificial intelligence entail, even in those systems that are themselves intended for risk assessment. Okay. So yeah. In the past few years, we have noticed obviously the potential of machine learning is immense. In the past few years, in the past 5 years, we have seen both in the private and the public sector, projects moving from proof of concept and experimentation into actual BAU almost and productionalized versions. This has meant that we have seen a lot more issues in the public domain than before. Some examples entail the very well-known Amazon AI recruitment system, which unfortunately, while trying to find the best candidate for a role, would kind of definitionally never pick a woman. And also the Apple Card example, which again, in quite a few cases, would give 10, 20 times less the credit card limit to the wife of the couple rather than the husband of the couple. And this has, while with similar income, similar credit, similar assets, and this has been, seemed to have been quite a systemic issue. In the health space, unfortunately, we have seen models being used in hospitals in the US where they would recommend a preferred treatment for a patient. And again, a systemic issue seemed to appear with certain groups, certain demographic groups be recommended treatments outside the hospital, which ended up leading to higher mortality rates among those groups. Now, these are all harms that are caused to kind of the subjects of these decisions, the almost the innocent bystanders, let's say, in these systems, or whether they're subjects or just actors around it. However, sometimes the system itself might not work as intended. In the private sphere, we see this a lot. We see, unfortunately, machine learning cannibalizing revenues for companies. The kind of example that has been whistleblown and talked about a lot is the Zillow, where they lost like a few $100 million, partly because of a faulty algorithm. However, imagine that you're creating a system where it's not about making money or losing money, but it's about safety and the implication that this might have, that a faulty system might have on your end outcome. Okay. Now, we've talked about kind of the negative outcomes of this, but the technical causes of these negative outcomes are quite important. They're not the only causes of the outcomes. There's a lot of organizational issues usually at stake. There's a lot of diversity issues that cause these issues. However, even for the non-technical people in the room, I would recommend, and generally for non-technical stakeholders groups, there needs to be an understanding of kind of the technicality of the issue, even if high level. Because ultimately, we're all, in some sense, if we're involved with these systems, we're all somewhat responsible for their outcome. So some of these issues, just broadly, this is not a comprehensive list, alas, but it's a good indicator, just something to keep in mind. For instance, sometimes a system might look very good on paper. All the metrics are kind of positive, the accuracy is high. It looks like it's going to predict really well, and a lot of times it does. And this being statistics, averages are important, and they're really kind of fundamental. But in some instances, some segments, be them customer groups or perhaps regions, perhaps supplier types, perhaps product types, perhaps transaction types, they might not be understood by the system well enough to really be able to be assessed. Which means that, if you try to use that model in that region, it's not really going to work. Secondly, I think with Corona, this has become more of an issue across the board in a lot of machine learning systems, really struggling to cope with changes in the data, changes in the environment that they haven't seen before. And a pandemic was a very good example of how that came about. Of course, if your system is no longer, the situation has changed so much that the system is no longer understanding what's happening, that's a really big issue. Explainability is not just about, the human in understanding the decisioning of the system, although that's the key element. But it's also the fact that, the human element cannot trust or really use the system or make a decision on the system if that level of understanding is not there. And fourthly, but in my opinion, in our opinion at Etiq, probably the most complex issue is bias. And I'll give an example that maybe it is often given, but it's not one you might expect. The technical cause for this issue could be, for instance, as in the potholes examples, so the city of Boston created this app for people to report whether in their neighborhood there's a lot of issues with the pavement, so they can go and fix it. The problem, of course, the people who kind of self-selected to report were people from certain neighborhoods with a higher socioeconomic status. And surprise, surprise, the end outcome was not really what the city of Boston was hoping for. Of course, this is a kind of well-known statistical issue, but it's one that it can plague a system from the setup, and there's a lot others like it. Now, we've talked a lot about kind of the problem, but I think obviously what I do and what we do at Etiq is not really about the problem. I think these are known problems. It doesn't mean that we shouldn't use machine learning, that it doesn't work, and all of that. It's just things that we need to address when we build these systems. And a mental model we found quite useful when addressing these things is that of trying to understand the process of build. And once it's in production, the pipeline, what actually happens to the data, when does it get stored, when do people get scored, when is the decision applied, and so forth. And when it comes to this, mental model, and I'll quickly kind of tell the story of what happens on the slide for the, I guess, non-scientists, non-ML people in the room. So let's say a data scientist team would take some data that has been provided to them, or they went off and found it. There's a level of analysis, there's a level of understanding. Then they try to kind of extract some of the factors. Maybe that's automated, maybe they do a bit of manual work there. Then they experiment with different models, and eventually they come across a version they like. Then they pass it on to usually a different team, depending on the size of the organization, and that team will productionalize that model. And then the model kind of runs at whatever frequency, and hopefully it runs well, and it's monitored. Now, it is easy to see that at every single step in this particular process, and once it's in production, at every step in the actual technical pipeline of the machine learning system, there can be potential specific type of issues, let's say, that have to do with the nature of the system. And if we reverse these issues, I mean, it's easier to kind of go to the solution, really. And if you know you're going to potentially have these kind of issues, then it's really kind of, an obvious thing to just test for them. And it's important to test for them at every single step, because like in the pothole example, the issue happened really early on. It probably, I'm trying to go back, but it probably happened like even before like the raw data stage, right? There was some sort of like intrinsic issue with setting up the problem there that really just impacted the whole system. Secondly, when it comes to testing systems, it's really important that the tests are not ad hoc, haphazard, they're structured, they're standardized. There has to be a level of versioning for the tests themselves that is applicable, well, hopefully in kind of best case scenario, to the models themselves. This is a system that should produce results that can be centralized, they're automated, the tests are not different from like when I ran it yesterday versus today. Like it's all kind of, it works as a system. And to just kind of demystify it a little bit, initially, it doesn't have to be like a super complicated testing system, really. What you're trying to do with the test is answer the question, is my model underperforming? Is it underperforming for certain segments that maybe the overall stats are masking? Is there bias? Is there drift, right? Is there leakage? Like, is it overfitting, so forth? These are things that can be quantified by relatively straightforward metrics to begin with. So the mechanic of the test, you have the question, you have the metric, and you have the thresholds, right? Very straightforward. Now, I'm just gonna go through this a little bit. Oh, yeah. Now, in the example of that Hans gave with the Bayesian network that was predicting fraud, food fraud, the kind of tests, a potential example of tests and the kind of tests that Hans and his team have been doing are like from the initial, as they were looking at the data sets, there was a lot of data validation there. As they were moving and kind of understanding, once they came to a model, they were kind of more or less happy with. There was a lot of model validation there. There was a lot of checks on on performance. once they started transitioning to a POC, from a POC to an actual production, they had to almost do like, it's not really user testing, but kind of run this by the experts themselves. Now, when they do that, the expert needs a bit of understanding of the decisioning that the model makes to reach a certain conclusion. The problem there is that if the model is a little bit more complex, the decisioning, the understanding of decisioning itself has a level of uncertainty. So, that's a bit of a problem that had to be kind of accounted for as well. And then once the model is live, again, things like drift can easily happen. Luckily, that model actually has amazing kind of alerts in place and automated retraining. But beyond this, the kind of key thing to mention this and why kind of centralizing tests and versioning and so forth is important is that it's almost like stacking. It's not that once you get to the last stage, great, you're done, you never have to validate your data again. These tests really get stacked, which is why important that they're part of like a proper automated framework. Like any system, I don't know why machine learning systems kind of get a pass from testing like a regular software system doesn't. Okay, in the case of, so this was, I don't want to say a relatively straightforward case because it wasn't. I think it's a very complex model. But in this case, with computer vision model trying to understand whether there is melamine in milk powder or not, or the bacterial issue with meat. These are really kind of hard cases to test for, and they're hard cases because there's a lot of edge cases in computer vision, and there's like the tests for them are very use case specific, right? Luckily, we do, this is an active research space, and not just use case specific, but also generalizable. There's a lot of research in causality, explainability, and also adversarial robustness that, hopefully will bring some light to this issue. And while I did say earlier that, initially you can start with a simple metric and see if it's above or below the threshold, for a system that really is intended for a very high-risk use case, you really need to start looking at this complex pipeline and incorporate it in your testing pipelines. So what does that mean? It needs, like, if you are in a sector such as yours, you need to kind of do very, very robust in-depth testing. I'm going to skip a little bit here, but something that maybe is a little less addressed in these technical talks is the kind of organizational changes that these things entail. Once again, we're in the world that moves from POCs to production to BAU functions where there weren't any before. And the organizational changes that entail is not just about the development of technical teams, although that's incredibly important, but also development of policies around the organizations that deal with things like transparency, robustness, the commercial implications, the impact implications of a certain system. And this really is not, is not something that can be forgotten or left out. A lot of the times, we see that the non-technical stakeholder groups are a little bit scared and a little bit worried about taking responsibilities for these systems, understandably, but they have to ultimately. This is not just with the technical teams, and having some systems, some policies in place should be able to get them to do so. Now, if it's all these stakeholder groups around the business who need to take responsibility, and yet maybe understandably the level of understanding of the details of those systems are a little bit lost on some of them, then what's the solution? I mean, I am kind of in the solution business. The challenge is clear, but the solution is a bit trickier. So what we're saying is that if you have a very detailed testing system, then like in a regular software development world, you can aggregate metrics. If that system is automated, it's standardized, works ongoing, it's a proper system that you put on top of your machine learning system and processes, then that can, when aggregating it, that can easily give you indicators that can be used by non-technical stakeholder groups. I mean, you really do not need to understand how a neural network works or how that specific neural network works to be able to ask for and receive an estimate of the risk involved in productionalizing that and running that system. So, unlike probably any other speakers here, I'm actually done ahead of time. But thank you so much for having me, and yeah, I'll be looking forward to some questions, hopefully. Thank you.
Thank you very much. Raluca, you may want to sit close to Dr. Marvin. So thank you very much for this very concrete insight in the testing of artificial intelligence solution, which is a key component, as I was mentioning, to being able to rely on the evidences and outcome that are coming out from this solution is very much important, the testing. And with this, I think we can open the question and answer. So we have a 15-minute slot to essentially address some questions that we are receiving through the app. And I don't know, Hans, maybe we want to start with the question that we have on the screen.
Yes, thank you, Ilaria. And please, colleagues, keep posting your questions and also keep adding likes to certain questions that there are already in the system. The first question is to you, Hans. It is about the data quality. It is from Gabriele Scholz, and quite a lot of people were endorsing that question. So how can you ensure that the data that are in your system are true or false? We know the principle garbage in, garbage out. So what are the possibilities that you see in order to ensure data quality from within the onset of the exercise?
Thank you very much for this interesting question. And this is always a crucial question. And I think you refer now to media-related or Twitter, the social media-related data, and not a real monitoring data of authorities, I guess. Yeah, what you do generally is the analysis and checking of the sources where this data is collected. So in our case, we use the infrastructure of European Media Monitor, and so it collects from all over the world, but we have a couple of years where we do really assess where the data comes from, read by a person, one person expert is reading the whole newspaper, just in order to see where, what kind of data you can use and can't use. And that you can build in your selection, and that you provide, that you decide to go further. So indeed it is always a important question to address, and I would say please invest as much time as possible in the data quality assessment. It is really important, because then you know exactly what you have.
Thank you very much, Hans. So we now have a question for Raluca. So there is a long history of new approaches or improvements where we recognize their potential early, but we do not recognize their limitations or instability as the area quickly expands. So the question is, how do you balance opportunities against practicality and not overhype the technology? So how do you leverage this opportunity vis-a-vis the practicality and the lack of confidence among the stakeholders?
Yeah, so I mean, I'm a big believer in machine learning. I think it's often better than the human judgment. So I don't think that it has limitation. It's like a fundamental obstacle. However, it's not uncommon, Hans was saying, data validation happens like as soon as, you're even looking at a project. This is not a step change from what the process should be anyway, but it is important to just give it its due. So like a percentage of time of a project allocated to it would be a good start. I think we don't see enough because a lot of these proof of concept projects have set low expectations in terms of timing implementation sometimes. So people just want to get it done quickly, and really they should allocate some time to the actual testing. I mean, because it's important. So that would be my suggestion.
And this actually prompts my question, that is, in an overall project in implementing this solution, what's the percentage of effort in the overall project in devoting to testing the artificial intelligence solution, you reckon?
Yeah, I mean, it depends. It depends how much of a risk case it is. So what is the potential detriment of the system, right? So if it's a really important case like the digital health one, that you should err on the side of testing it more. If it's a marketing use case, then it's just money you're really spending unnecessarily. So it's just money you could potentially be losing. So somewhere around 20% would be a good benchmark for these more like lighter versions. And in the case of a high-risk system, then it needs to go much higher, to 40, even 50%, I'm sorry to say. But if you look at the safety space, that's where the issue is with a lot of these like high-risk systems.
Thank you.
Hans, I have another question for you. It's more about precision and accuracy of the systems that you have been showing. In a certain example, you mentioned 90% of accuracy. According to you, is this sufficient? And also, are there certain maybe performance criteria that are being developed for this type of approaches that you say below a certain level it is not to be used, or are there criteria for accuracy, for precision, and what is your feeling about that?
Look, again, an interesting question. Yeah, the accuracy is really important. First in the method development, so when you have the model itself, but also for the future, whether it remains the same accuracy. And generally, when creating the models, develop the models, we have always a very tight connection between the modelers, the data scientists, and the domain knowledge experts. And it is an iterative process all the time, building, testing, validating, consulting with the experts, again, adapting, and so on. So, maybe there are around there, let's say, models for determine, let's say, the accuracy, what threshold is acceptable. Generally, we do it in a way, for example, if we have a completely new system, it is the user who determines whether it is acceptable or not. It gives the probability when we talk about a business network. If the accuracy is really high, we get suspicious. But sometimes we have 85 or 90, 98%, and then we have a really thorough check of all the data, whether there are imbalance, what causes the high accuracy. What we also do is, and for the food fraud, for example, we made a model with a performance accuracy of, let's say, 92% in 2015, and we checked the model without any improvements, so not with new data, how it performed on the prediction of the situation in 2020. And it was quite accurate, to our surprise, even without the new data being inserted.
So if I may ask you a follow-up question, how precise are the the methods that use smartphones to look at food contamination?
Yeah. Well, there are good other methods, just connecting a device to a smartphone and then transfer, and so the devices, Raman or NIRS and other type of devices, they are very quite accurate and also a low, sufficient low. At least these are being developed, or for mycotoxins. The one I showed you with the pictures, just taking a mobile phone picture, this is really new, and so. Yeah, we have above 80% accuracy in the models that we made, but we think we need to develop further in order to be able to use this as a kind of screening. And that's what we are saying. It is a screening tool that you can use for selecting the samples that you will send to the laboratory. But of course, that should also be accurate enough. But I think we need some developments there.
Thank you, Dr. Marvin. So we have another question for Raluca. So representativeness is difficult to test and ensure if populational for which is intended is somehow not considered when data is collected. Experimental settings are not really seen when talking of big data. What do you think about this?
Yeah, that's true. One, I'd say there is some potential for experimenting, again, some use cases, but not all of them for sure. Secondly, I think, of course, it's very, very hard to get like perfect representation, and that's normal. But I think if you productionize the model and then you don't put some alerts in place, then what tends to happen is things that you could have picked up, you don't. So, no one kind of expects, I think, anyone to just kind of know everything. I mean, because then what's the point of the model? But it's more if a group appears in the model that you're not really, the model doesn't really understand properly. Maybe it's a new group, maybe whatever the situation is, and you need to notice this as soon as possible. And then there are some, let's say, maybe don't have real life outcomes straight away. Like a lot of time in lending or in a lot of use cases, you just don't know the truth till long after the decision was made. So then, even in those cases, there are some indicators that can tell you there's a problem there. Like if you're not lending to anyone in that group, then there might be an issue. Just just a heuristic. But yeah, that would be my suggestion.
Thank you very much. So I think possibly we have another minute for the last question. Do we want to probably have another question for Hans? Can we estimate human time saving using artificial intelligence for systematic review as an average? We always say it saves a lot of time. Any metrics is available on this matter?
Yeah. How much time it will save? Yeah, I think we estimated around 30 to 50%. But it also gives you the opportunity to include by far much more abstract. So now you are looking at millions of abstracts, not excluding through the step-by-step keyword selection, and in order to get it to a manageable size of abstracts and titles that you then first screen, and then you go to the full paper. So you for sure by doing that you will miss because you cannot read everything. But with this algorithm, you take those that you normally would miss, also will pop up. So I think you have a wider view on the scientific literature using artificial intelligence in the systematic literature review, and you are saving time, especially if you do it second and third time.
Maybe if you allow one last question to both of you, but then with a very short answer. A risk assessor may want to understand what the drivers are or the risk factors that drive the outcome. Is this, according to you, a challenge or maybe the most important challenge for the use of machine learning? Do you have an opinion about that? Maybe very quickly to wrap up.
I have a good opinion. We have spent most of our time on that. And there's a lot of expert consultations you have to do in order to have a wide picture of the drivers. And sometimes obvious drivers are not as powerful as the others. So that's why I say a system approach is needed and a complex, because it's a web of interaction, and AI and Bayesian network has shown us to be very helpful in that.
Yeah, I mean, I think for some use cases, for sure, this is the key issue in terms of adoption. But I think, unfortunately, there's many other issues that also need to be solved. So my answer would be no. But
Thank you very much. And colleagues, this brings the first part to an end. I would like to thank very much Hans, Marvin, Raluca, Crisan, and also my co-chair Ilaria. We have now a short coffee break, and we will be back at 10:35 for a continuation of this session. Thank you so much to all of you.
And thank you from you as well.
Come back into the room and take your seat and join me together with the people that are following online the second part of our session. Let me just introduce to you Jennifer Baker, the moderator of the second session or the second part of this session this morning, who is a journalist and a professional moderator, and she will guide you through the second part and the discussions that we are going to have now. Jennifer, it's yours.
Thank you very much indeed, and thank you to all being in the audience, and for the audience joining at home. A reminder to everyone that that app is open for your questions. I'm telling you now so that we can get plenty in and collate them and get as many as possible to our great speakers. Now, today's panel, we're discussing considerations and recommendations for a concrete adoption of AI in future risk assessments. And we saw our two keynote speakers very eloquently set out the opportunities and indeed the challenges. So we're going to tease those a little bit more in this discussion. Of course, big key points we want to discuss are trust and bias in AI, the role and accountability of AI, maturity and explicability, which I think is one that is often sidelined in these discussions. We got very much involved in the how without saying, well, where are we actually at today in 2022? And then concrete adoption of AI in risk assessments. And just to let you know, a social media campaign was carried out in April and May on LinkedIn, just in advance of this conference, asking people which of the various points was most relevant for them. And in fact, out of the votes, not scientific, of course, more an artistic endeavour, but we got nearly 300 votes, and the majority of people, over a third, said availability of big data and opportunities with AI technology for applied risk assessments was their chief interest. There were also then almost neck and neck ethical aspects in adopting human-centric and explainable AI, and the role of AI and humans in future risk assessments. So I think those two are fairly linked, so we can see why they came up with a very similar result. But then last but not least, we only had 2% voting for concrete steps. I think people are more concerned with how they should do it and what they should do it, and see it more as a journey rather than a destination, which is probably as it should be. So I'm heartened that the audience seems to be on the same page as we are for this discussion. So with that, I'm going to introduce you to my fantastic panelists, because you want to hear from them, not from me. We have Ivana Bartoletti, who is the Global Chief Privacy Officer at Wipro. Marcus Lipp, who is joining us online, thank you very much, Marcus, is the Risk Assessment and the Senior Food Safety Officer, FAO. So Wens van der Schot over here is also full professor at Utrecht University and coordinator of the open source software project AS Review. And Akos Jozviak is the director of the Digital Food Institute at the University of Veterinary Medicine in Budapest, and also is heading up the EFSA Advisory Group on Data. Thank you all very much for joining me. And I'm just going to leave you an open 3 or 4 minutes to set out your stall. Tell us what you're working on. Tell us why you think today's discussion is important, and give us a bit of background on yourself. Ivana, let's start with you.
Oh, just, sorry. Okay. Normally I spend a lot of time trying to find a button. But okay. So first of all, I just wanted to say great to be here. Thanks so much for inviting me. And it's an amazing discussion, a very timely one. I work as a Global Chief Privacy Officer for a global tech giant which is Indian. So I spend a lot of my time, as you can imagine, as a sort of counsel when we develop a product, when we do a project, and looking at how ethical it is, how privacy compliant it is. I established a large privacy and ethics by design center of excellence when we look at privacy enhancing technologies and all of that. But I'm also a visiting policy fellow at the University of Oxford in the UK, where I look very much at issues around privacy enhancing tech, and especially in the area of data sharing, which is also a big issue for you. So I wanted to, if I've got 2-3 minutes to set my stall, I just wanted to say that I'm an optimist, but when it comes to this, I have some big reservations. And the reservations need addressing, and I am very passionate about addressing them if we want to make the most of the use of artificial intelligence and big data. And I'll just make some quick points, and then hopefully I'll create a lot of discussions because I'm very controversial by nature. So first point, when I hear the word big data, it's great, fabulous. I am very concerned about the missed use of data opportunities, but I'm also very concerned about misuse of data. Especially you in your field, we've got to start with the assumption that data cannot be treated as a neutral thing. There's a lot of enthusiasm at the moment around data. Data is great. And it is. It is fabulous. But data is not neutral. The way that we collect data is not a neutral thing. Any data collection implies a choice made by somebody, an organization saying we're collecting this, we're not collecting this. Somebody's elevated to a data set, somebody's left out. Never neutral. So my first point always is we've got to become very critical in the way that we look at data. If we want to make the most of data, we've got to understand that data is not neutral. Second thing, we live in an era where we are looking a lot at techno-solutionism, right? Where we're looking at solving big societal and problems in our society with the use of technology. So technology is fabulous, but cannot solve problems that need much wider addressing. So it's really important that we keep this in mind, because especially organizations like yours, we've got to be very straight, very clear, and say, what are we using technology for? Third element that I wanted to say, very relevant to this. AI is not just about big data, it's not just about an algorithm. AI is about infrastructure, it's about supply chain, it's about relying on these big things that create a lot of environmental pollution in our world. Right? GPT, when it was used and when it was created, the way it was trained, it required the same energy of maintaining the 130 cars in the US. Okay? It's not cost-free from an environmental perspective. So one of the big things that I would like the big things that I'm working on at the moment is really how we create, and I've got I'll stop, but I've got a 5-step roadmap for this that I've developed within my own company, and I use with the Women Leading in AI, that's an organization that I lead, which is really around how we make AI not just for sustainability, not just AI for risk assessment, not just AI but also sustainable artificial intelligence. And organizations like yours looking at some of the crucial issues of our world, sustainability is very much related to this. So the reason why I'm setting the stall here is to say a lot of opportunities, but also we need, and message that I would like to give you is to really make the most of the opportunities and lead in a way that is sustainable, responsible, and ethical.
Thank you very much, Ivana. I don't think anyone's going to disagree with that in principle. I think the arguments will come later in our discussion. Marcus, let me call on you. Tell us a bit about what's going on with you, what the Food and Agriculture Organization at the UN is doing, and where you see the intersection with AI.
Thank you very much, and the congratulations to the organizer of this conference. It's very interesting to see all these different viewpoints here represented in the keynote, but also in the panel members here. So very exciting opportunity to have a more holistic discussion about AI and machine learning. Now, the nerd in me, the technology-oriented person in me, is very excited when I listen to Hans's presentation and the capabilities that are emerging. And yes, there are many, many technological problems to be resolved, but there is a certain inevitability of technological solutions. So AI is here, AI will come into risk assessment, into food safety risk assessment, the topic here, and machine learning, and it has been applied for years already in various forms, and it reaches a level of maturity where we can have events like today. And that's fantastic, and that's great, and huge amounts of work have been gone into this approach. Where we are a little bit more thinking about, might be the right word, is the governance. What do we owe consumers? What do we owe other governments around the world in terms of explanations? So when we look at the political situation, currently there is that a loss of trust that seems to go around, and so fancy way to put that is the epistemological authority is questioned. So who has the right to say which science is right, which fact is right, which evidence are right, which data are the right data to be included, and how does that then evolve over the future? I think that's a key concern, because also with some of the advances that are proposed in AI and machine learning are that we almost outsource that epistemological authority, that knowledge base that was human-centered, and humans can be interrogated. That's a big advantage, and I'm not sure that we understand fully how to interrogate AI. So sitting down with a human or with an expert panel and say, what were you thinking? Why did you come to these conclusions? Please, step by step, talk me through. That's possible. To do this with AI is much more trickier. Now, and then to explain that to the non-technical experts, food safety risk communication is hard enough as it is. And we have no, I venture to guess, we have no good approaches there, because we typically, FAO and everybody else, bank on the science, and that the science will ultimately convince people. But that's typically not the case in food, because food is such a highly emotional topic. So when we then compact food safety risk assessment and food safety in general, and have to explain that we use complex artificial intelligence systems that we may or may not fully understand what they exactly do, and we can or cannot fully interrogate on how specifically they came to such conclusions, that's a problem. And I think that's a problem we need to very carefully consider. Now, humans make mistakes. Humans build AI. AI will make mistakes, and Raluca has very eloquently pointed out some of them. There are many more things that went wrong with attempts from AI that magnified biases in the data set that I'm certain were not consciously built into the data set, but then magnified it. So one of the risks with AI, which I think also deserves some attention, is we will make mistakes. We always do as human beings, but we will make them much, much faster and a much bigger scale when using AI and machine learning. And if that affects areas like food safety, then it affects the health, the livelihoods, and the well-being of many, many people, which will trigger a very close analysis on how to communicate this in an appropriate manner, and how to maintain, increase, and hopefully increase trust of the consumers, trust of all the stakeholders in the food supply chain, that these processes are under control, are not knowable, and that they will then apply appropriately. Lastly, maybe my last point, we've heard a lot about big data, and this is wonderful, and how to milk big data. Now, in principle, these learnings that we have from synthesizing outcomes out of big data sets can be reversed, and it is perceivable that there are interested people or groups that would use those technologies to generate data, to actually introduce consciously a bias into big data sets. And that might be especially a concern if we look at distributed federated learning systems. And again, calling for the governance questions, who can make judgment calls, or what frameworks do we have in place to evaluate which data will be included and which won't be included, and why? So I'll stop here, but thank you very much.
Thank you, Marcus. You've raised a lot of issues that we will be certainly going into more depth on. Akash, I'm going to come to you next, because we were talking just there at the end about data, and I feel sometimes when we say data, we might as well say talk about money or talk about air, because there's so many different sorts of money. What do you mean? What do you want to do with it? Who owns it? What type of data is it? Tell me a bit about how you're interrogating that.
That's a nice question. Well, I would start from a bit of philosophical background, in a way that food safety or food science deals with the food systems, and food systems, by definition, they are a complex system in a mathematical meaning, and we many times forget about this. So mathematical complexity will mean that we have to experience like sensitive dependence on initial conditions, emergence, a lot of relationship between the points in this system. And this could be addressed only or mainly by different complexity science solutions and tools. So our way of thinking about food, besides it's very emotional and we like to eat, it's a very interesting field of complexity science. And for that, we need complexity solutions. And for that, certainly we need AI and other tools as well, not only AI, but it's, I think, a broader context, a bit like network science also plays a role here. We are focusing very much on AI, but it's not only AI. And for these, we certainly have to explore the possibility of addressing this complexity, addressing big data. But I'm not coming from a data perspective per se, but I'm coming from that perspective that is very complex, and one of the way of interrogating complexity is to interrogating data and information available in this complexity. Also, what I would like to add to this, that we are talking about many different things today, and generally when we talk about AI, there is a huge gap between AI solutions which are available out there for different domains, and this is like the 23rd or 24th century already. And there is this reality of food science in every day that we struggle with data collection at a member state level, and we don't know anything about our food business operators, more or less. And this coexisting reality, in a way, it causes a lot of tension. And I know, because I talked with many of you, that this is still a big issue, that many of the data scientists think that we are too old to jump on that AI train, because we don't have the data, we don't have the knowledge. It's all messy. We have this computer-assisted vision and a lot of sci-fi things going on, and we'll not understand ever what is happening. And this is fueling all the debate about the black boxes as well, because in my opinion, black boxes are very important, but it's not very different from if you want to assess a validity of a statistical analysis. So there are different tools and maybe a bit different setting, but this controversy about black boxes is coming, I believe, from the fact that we food scientists are very far away from AI, the AI word. And what I wanted to, the third thing which I wanted to stipulate here is that it was already mentioned that AI or complexity sciences need not only the data or the algorithms, they need infrastructure, architecture, they need data models, they need applications, they need integration, which is a very hard thing to do. But most and foremost, it needs data literacy. We need to understand what's going on. And in some of our experience, we see that I'm a veterinarian, and I can tell that in the veterinary curricula, there is no word about data science in Europe and nowhere else. And it's more or less true for food science as well. So we learn and teach statistics, but not data science, not AI, not the whole data domain, and complexity sciences, never. So this is something which we have to start, to be honest, because it's also a part of the trust issue that because we don't understand, we feel that it's very far away from us. We feel that it's black box. We feel that we never can understand what's going on. We distrust. We will not accept the results. Or maybe we would accept, but with certain limitations. And the only way, I think, to solve this is to start very early, even in primary schools, to talk about data literacy, bring it to the veterinary food science curricula, and talk more and more about these. It's a long-term solution, I know, but we have to start someday because it will be a long-term solution in 20 years as well. So this is, I think, the main message from me, that this is how we shall move forward. Thank you.
Thank you very much. And you've raised some interesting questions, I mean, almost around the idea of what we understand as AI. I mean, the predictive text on my phone is an AI. You know, the sort of automated processing, that kind of boring work, it's almost, it's, you know, it's not artificial intelligence, it's artificial stupidity. It's just doing repetitive, easily understandable tasks. And I mean, from that side of things, it's just useful in terms of the volume, the velocity, and the vectors, if we want to add in a third V. But I think where we get scared about things like black box is when it gets more complex, and particularly where it ends up in things like proprietary software questions. So, Rens, I'm really interested to hear your take on what it is we're actually talking about today and how that feeds back into the risk assessment question.
Yes, and thank you for inviting me, EFSA people. I'm actually specialized in small data, so maybe I got the wrong invitation. So what am I doing here? So I'm going to tell you a little story about some of my research lines to explain actually what we're going to do. I'm working together with the Institute of Burn Centers in the Netherlands, and we're trying to apply advanced machine learning models to predict post-traumatic stress trajectories of children with severe burn injuries. Now you know why I'm not working with big data, because we want to have this data set as small as possible, right? I mean, we want to have big data, but for some situations we don't want to have big data sets. But still we want to apply advanced machine learning models because we need to predict who is developing post-traumatic stress, which of the children need therapy, which of the parents need help, which of the siblings need help. So how can we turn this small data set into a bigger data set? We often use transfer learning. So for example, we ask experts and apply elicitation procedures to ask experts, nurses, therapists, about information that we can then add to the model. This is called Bayesian statistics. Anyone familiar with Bayesian statistics? Oh, cool, I see some people heading. So we have prior knowledge, background knowledge, which we combine with data, and the two pieces of information contain more information than the data on itself. So how can we turn a small data set into a bigger data set? We can collect more information from the same individual, or we apply transfer learning. And one method to apply transfer learning is to do a systematic review, which you're probably all familiar with. Many safety guidelines are developed based on systematic reviews. So you can go through the literature, find information which you can then combine with the observed data, and then you have a bigger data set. But now the question is, and then we're slowly tagging into the problem of software, how to find relevant literature. So you do a search, you maybe find 10,000 potential relevant records. How to find the 5 or the 10 that are relevant to your use case? Well, we can apply AI. We've already heard that in the keynote lecture before. And we're also running a large open source software project. And with the help of AI, you can actually reduce the screening time with up to 95% of your time. So instead of reading 10,000 articles, you only have to read 200 to find the same relevant papers as you would have by just reading all of the 10,000 records. But then think of screening fatigue. Think of all the things you could have done instead of screening articles. Is anyone doing a systematic review here? Is anyone familiar with, I see some hands here. Yeah, you as well? Oh, cool. But now the question is, how can we trust the decisions of the AI? So what does this software need to do so that you actually trust the result? Because the software is presenting you an abstract to read based on your historical labeling decisions. So how does this AI does this? Well, can we just put all the code openly on GitHub so that you can read it? But who's actually reading Python? Anyone familiar with Python? Fewer hands here, a few. So documentation is needed, but then still we can document all the lines of Python code, but that won't help you. So we need explainable AI. We need to explain why the AI is presenting you this abstract and not the other abstract. So it might be that there are relevant abstracts that will never be shown to you as a human. Do we accept this? But then humans make mistakes, AI make mistakes. So how can we forgive the AI making these mistakes? Or should we not forgive the AI in making mistakes? I think it's time to start the discussion.
Yeah, I was going to say, I don't think the AI's feelings will be hurt if we start to blame them, but...
AI has feelings. or maybe not.
Maybe not. Ivana, let me, both Marcus and Akash mentioned the fact that, food is emotional. I think it is also, perhaps even more importantly, cultural as well. And when we talk about risk, we're making value judgments. How can we, if you like, outsource that to an AI? Should we outsource that to an AI?
We don't, but I just wanted to say, the word that I've heard a lot is this word of trust, right? Which is very much related to what you're saying. Now, I just want to go one step back when we talk about trust. We live in a world where we don't trust any of the objects that we use. That is, when we do like this sort of, there are surveys going around and say, do you trust your iPhone? Do you trust your Facebook? Do you trust it? 90% of people say we don't, but they do it anyway. We use it anyway because we haven't got any alternative, right? But a world where we've got to use tools that we mostly don't trust, we've got to use them because there is no alternative for many different reasons, competition, that's why the EU is tackling that. Okay? We are forced to use these tools. We often don't trust them. Right? We don't believe what they're saying to us, and yet we use them. That's what is often called an abusive relationship, isn't it? The reason why I'm saying this goes to the first intervention here, which is the fact that we live in a world where, over the last few years in particular, the basic tenet of trust in particularly technology is not, has gone down quite a lot. Data collected for research purposes, used for political persuasion, Cambridge Analytica. Data used in manipulation, false information, fake news. People don't trust this anymore. So when we talk about trust, we've really got to stop and say, what is this trust that we're talking about? If trust is that an algorithm, a decision has to be explainable, I disagree. Explainability, fine, but actually, you have to be an expert to understand a decision, right? Explainability has to be contextual. If I don't understand it, then we're back on the problem of the privacy notices, where there is 3 pages, and I'm a privacy person. We go to the 3 pages of privacy notices that you have to consent to, agree to, but most of the time, we don't understand it. That's why the issue here is how we put the onus a little bit away from the citizen to the regulatory element. So a little bit like what the European Union is trying to do with the European AI Act. We're basically saying you're a producer of AI, you're a user of AI. User is not an end user. User is a company that purchases an AI system for another company. When the producer creates an AI, it comes with a list of things, values, a list of things that is sold with the product, and it says exactly what the AI is made of. the values, that is sort of how the AI makes decision, and this sort of certification, this sort of doesn't go to the general public, but it's part of the acquisition of an AI system. Now, we can discuss about the European AI Act. You don't want to. Because the European Act, whether it's, you can regulate AI in the same way that you would regulate a washing machine, but that's, that's very much of a separate discussion. What I'm trying to say is that AI is made by humans, isn't it, right? It has an algorithm or an AI system, some people say is an opinion in a code, right? It represents the values, the data that humans put into this system. It's not independent from us. And is therefore, we've got to be really careful when we produce these systems that we have the right tools and controls in place, so then we do not do something that automate and puts in software, for example, like Raluca was saying so well, the existing sort of inequalities and the existing that we have in society right now. We live in increasingly so when these machines make decisions about us. They assist policy making in making predictive, help us draw predictions, help us make policy priorities and define. But of course, these things are not neutral. These things are, these things represent the decisions that somebody's made. It's made of which parameters. It's not just about the data that goes into a machine, it's also about the parameters that are chosen. Is whether, for example, a product, an AI system is developed in one place and trained with some data and then is used somewhere else, and then it latches onto data which is in a particular area, and then you bring it to another place, and therefore it doesn't work as it should. These things have got enormous consequences. Enormous consequences, an imprint that goes beyond the life of the machine itself. So, what are the consequences of this? That we need appropriate governance in place in organizations, that we need scrutiny, that we need regulation at the beginning of the process and all throughout the process, and we need participation and involvement from citizens and from those that are going to be impacted the most by these systems.
And proper training.
Ivana, you said you didn't want to talk about the AI Act, but never underestimate a Brussels audience. I would say, however, that you've actually gone about explaining the AI Act's approach, which is a risk-based one, which is to say, well, if I buy the wrong color lipstick, that's not, you might be high risk of that, but it's not, in terms of damage to me, a big problem. If I ingest something that is going to make me ill, that is a big problem. And the AI Act at EU policy level is currently working on this sort of pyramid of risks, which I think is why we say, oh, I don't mind if I don't understand how this works, because it's not going to harm me fundamentally. But people do need bigger reassurances, the bigger the risks for potential harm. So, Marcus, let me bring you in to discuss do you think that's the right approach? I'm also going to mention that Herman Dirks here on our audience has said, we've heard a lot about the risks of AI, but should we not put this into perspective and compare it to the risk of human error as well? Marcus, I'll let you take that.
I think it's a fascinating discussion, and of course, there's never an easy answer, like for most interesting things in life. Of course, humans make mistakes, but intrinsically, we as humans want to hear a justification. We can interrogate. We know how to interrogate another human and make them explain what happened, and then we may forgive them, or they may go to jail, or whatever happens as a consequence. But we have these processes in place, and we know how to operate them, because that's how humans interact with each other. How would we interact or interrogate an AI? And what would happen if the AI is wrong? Do we send the computer to jail? I mean, there is no equivalent to that, right? So, oops, the system failed us. And then we are stuck with that, and we still have to live with the consequences. These questions of accountability and liability are generally not well handled currently with all these automated systems. And they become really, really a problem in some of the issues that Raluca actually very nicely explained or mentioned. Now, there's another dimension that I would like to bring up just to make our lives more complicated. And AI and data, big data, requires an incredible amount of resources in terms of money, in terms of the tools to generate those data, to host those data, to connect all the computers, so internet structure and the power availability and all these good things need to be in place to operate these systems. And that doesn't take into account the sustainability argument that Ivana already mentioned earlier, whether it makes even sense, but that's a different topic. As FAO operates on the global level, we have 194 members, I believe, member countries. Our concerns are often also include those needs and the realities of low and middle income countries. Now, Europe promotes AI, of course, in regulatory science. EFSA is very active, and there are other high-income country food safety authorities do follow suit, of course, and have their own programs. And that's all fantastic. We need to proceed. We need to drive these technologies. Technologies will emerge anyway, and we need to harness them or evaluate how we can harness them. But what would happen if there is no access to these technologies from low and middle income countries? May it that the human capabilities and capacities are not there to operate these systems, that there are just not enough experts in the country, that the infrastructure is not there, that the data cannot be generated at the same volume. So then we have this competition about who has the bigger data set and who has the right data set. And my model is better because it's based on more data than yours. I don't think that will help ultimately, and I think it will lead to some very unfortunate and unhealthy outgrowth that we would rather like to preempt, or at least very, very carefully help to manage, that low and middle income countries do not lose access or do not get disadvantaged even further as this new technology emerges and takes a hold. So that's just an additional dimension that I would like to offer for everybody's consideration. Thank you.
Well, Marcus, I don't know how well online you can see your fellow panelists, but you're certainly provoking a reaction, so that's great. You say you don't want to send the computer to jail, but of course, that's the sort of question where, if you like, with self-driving cars, we're currently grappling with this question of liability and where it lies. So there's a relevant part to that question as well. And I'm just seeing online some of the comments as well. Karsten Behring pointed out that current AI is capable of doing what a human brain can do in 0.2 seconds, asking which part of food safety risk assessment can be split into tasks of that length of time. I also see David Gott asking, should we start with the small steps, for example, systemic reviews where AI might help and make them more usable and timely, while at the same time developing a framework for other areas? David, that's a tremendously diplomatic and very reasoned suggestion, but we don't want that. We want arguments. So, Akash, tell me what your thoughts were.
Thank you. I would like to slightly disagree with the previous statements. I mean, yeah, they are generally true, but in terms of liability, the one example is the autonomous cars, and they are coming to an agreement that the producers will be liable. And also, when it comes to liability for an older entity, like companies are liable. They are not, they are virtual entities and still liable for their decisions. So that there is a way around to solve this. These are solvable problems, I think. Another important issue is that how expensive or resourceful or need of resources for AI is, that more and more models are deployed on cloud. And if you are a small country with no money, you could very easily, to be honest, use AI methodology for your data sets. It's not a money question currently, partly, but it's about, do you have the knowledge and the people and the willingness to do it? And it's a far bigger obstacle currently in coming from a small country to grab the expertise around, to have the right people, to have the right questions, and to decide that you jump on the train. But if you do this, the money and access to AI algorithms is not currently the problem. And the third thing which I wanted to add is just reflecting to one of these questions, that yes, we need to start with the small steps. So this is, again, this big word and discussion maybe on the artificial general intelligence, that what will be capable of and what are the liability and ethical issues, morality, big questions of science, how we do science in the future. But in real life, we are talking about very narrow AI and very narrow application, and we still don't have the data. We still struggle with having the right amount and right quality of data on food safety. And this is the starting point. I mean, this would be, we miss, compared to, for instance, public health or other domains, and I think public health and health industry is very close to food science. Compared with them, we are like 20 years behind at least. We don't have basic ontologies on food categories. We don't have basic ontologies on some of the animal disease. So we miss a lot of the really basic background infrastructure to be built on. And this is something which we have to work on, because talking a lot about AI and how to use it is becoming in a way theoretical if we don't have the data. And data collection, data generation, also systematic reviews is one of the ways of interrogating information and data coming from outside. That's I think a very important part in our job. But also generating more and more data, how to use industry data, how to use other data sources which are already available. This is something which we have to explore. Yeah, thank you.
Well, absolutely. And I mean, José Cortinas Abrahantes has made a good point, saying, why is the trust only a problem when AI is used? There could be a problem when any risk assessment is performed. And I suppose humans, if we're working off faulty data or incorrect data, will also garbage in, garbage out. So Ernst, talk to me a bit about data hygiene.
Yeah. Give me your research question and your data, and I will give you a significant answer, right? So at the university, we're training the next generation of data scientists. They're coming to you, right? And now, this year, next year, and the next generation thinks differently. I was recently talking to one of the younger people in my group, and I tried to convince him that in the software we were developing, we need to explain that AI was used, and we needed to make the user of the software aware that AI does something. And then he told me, no, I will never use websites or software that does not use AI. So you should turn it around. You should tell the user, this software does not rely on AI, and then it will not be used by the next generation. So I disagree with the small steps. The next generation is taking a major leap forward, and people, we are lagging behind. I'm feeling old now.
Well, let me push you a bit on that. I mean, there are inherent problems with, I think Akash identified sort of who has access to the big data sets, who has access to the processing power. I mean, this is before we even make the leap to quantum. You know, will there be, if we're talking about something like regulatory authorities, if we're talking about assessment agencies, outside of the, if you like, the commercial space, are we going to see countries, regions, peoples, societies left behind because they don't have access to these tools?
And this is bias, right? So we're talking about bias in AI. I think this is a different level of bias. But think what our phone can do nowadays in comparison what our computers could do 10 years ago, right? So the developments are going at a fast pace. I don't think this is an issue. I hope this is not, I hope this is not an issue. And I really think that the next generation has access to computational power beyond what we are using today, and that the issue of data phishing is over, because an AI can just run all possible analysis instead of the one that produces significant results.
Marcus, is it an issue, Marcus?
I think from our experience, it is an issue, it will remain an issue for quite some time, because yes, in theory there's cloud computing, but that's just outsourcing a problem, and not everybody is comfortable to contract to an entity that's not even located in their country, vital data and vital systems. So there are all kinds of issues regarding national sovereignty, if we go down that route, that need to be considered, that are not that easily addressable, like ransom space from AWS or Azure or Google. That's a solution in many countries, particularly in higher income countries or in fairly developed regions, but it's not the reality in quite a number of areas in this world. Now, one of the aspects that I would like to come back to, I mentioned it only briefly, and this is data generation. So particularly if we're talking about regulatory science, so data that are useful for risk assessment or are key data for risk assessment, not just informative data on the side, they are super expensive to generate. If one wants to understand what is the exposure of at the population basis, so for a whole country, for specific contaminants or food additives or any other thing that is in food, this is a really expensive undertaking to do. And that's where resource limitations that many low and middle income countries do experience become absolutely apparent. And then these data are just not available. Maybe the models are available to deal with big data, but the data are not available. And hence couldn't be applied because there's nothing to apply those models or AI to. That is already there, so that's not new. But that gap will widen if we don't pay very close attention, and that will show an impact in trade, that will show an impact in livelihood, in food security, and will continue to create more inequality. Fundamentally, that's where it comes down to, and that is a concern to us, at least to FAO, to me. And I think that's a discussion worthwhile having, what we can do to actually, well, at least slow down, or if not minimize that gap, slow down the widening of that gap at the very least, because otherwise it will create another level of unsustainability on the global political sphere, at least. Thank you.
Well, I think, Marcus, you pointed to something that I know the European Commission is already, at an EU level at least, taking stock of. We've seen this push towards data sharing, data governance and the Data Act. Apologies, I'm a technology policy journalist, so I tend to get bogged down in these nerdy discussions. But there are steps to address these problems, but possibly not at a global level. I'm going to look now more specifically at some of the questions we've got coming in from the audience at home and in the room. Again, a big reminder, please do use the app. I am keeping an eye on it. A question for Ivana. Robert Van Gonkorm is asking, we're afraid if AI and computers take over the decisions, but what if we see AI as a screening tool that will always need confirmation by humans?
I mean, I'm not afraid of AI. I'm afraid by humans. As simple as that. I'm afraid by humans because we are biased. We make the wrong decisions. And when we ingest our values and when we ingest our bad decision making into the machines, we end up automating a large scale our bad decision making. So this is why, and I just want to point out, to close on this, from, this debate around the machines made mistake. Yes, we know, the humans made mistake too. Oh, yes, we do know that. And that is the main point. In a world where these machines increasingly have an editorial function, they decide what we see when we go online. In a world where these machines have allocative functions, they decide which policy-making priorities we're going to have. When they have a decision-making function, increasingly so, we end up automating all this sort of bad human decisions-making that we know really well in a way that it becomes more and more difficult, less accountable, because it's less accountable when it's done in a way that is not understandable by us. That is the problem. So, so that I just wanted to clarify that, because I think we need to get out of these discussions around, yes, but the machines also make mistakes. The humans also make mistakes. It's a separate problem. Nobody's saying that is not true. We're actually saying that the real worry is when the human bias, the human sort of inequalities, the human even racism is then embedded into these machines and becomes software. And the problem is that there is a very difficult to then challenge. Very difficult to challenge. How do we know that an outcome of a specific system is what is leading a particular decision. I'll give you, just a quick example. If you have a local authority, right, and you use a predictive analytic systems to identify, for example, which families may be at risk of a particular problem 10 years down the line, right? You may end up wrapping some particular surveillance around individuals because historically, for entrenched inequalities in our society, historically, these people have ended up in poverty. By wrapping surveillance around some individuals because historically these individuals have been failed by society, does it change things or does it actually entrench it even further? That is the key issue. I would love to use AI for good, fine, but AI is done by humans. That's what I'm concerned about. One solution is to say, well, we can use AI and have a human in the loop or the human on the loop, and the human makes machine. Again, if the human review a machine is the same human that I've been talking about before, so that's not a silver bullet.
I mean, I think it's also about who's involved in those decision-making processes of who makes the machines. I know Raluca gave some good examples. Have you heard, hands up, have you heard the one about the racist faucet, the racist tap? No, there's a wonderful team of people working away in Silicon Valley. They were creating a new water faucet, a tap that would sense the temperature of your skin and make sure that when you put your hands under, you got exactly the right temperature of water to wash your hands. And the team were trying, and this was great, worked brilliantly. And an external person came in, a black person came in and put their hands under, and it didn't work because no one had thought to test it on black skin because the people involved in making it, were making, and they did it with the best of intentions. They didn't intend to create a racist tap, but they created a racist tap. So that's for hand washing. I mean, it's an amusing anecdote if you're not affected by it, but think of the broader consequences. Akash, yeah.
May I add two things? One is that, I completely agree with all these examples and all these concerns and challenges. But first of all, this is a well-known, bad study design. This was true before AI. If you don't know your model and you assume not the real things, you end up with bad decisions irrespectively of AI. And this is something which we have to consider, that's right, but it's not an AI-specific problem, I think. Another one is that I think we have to make a difference between using AI for certain decisions where from the beginning to the end there is a machine making a decision, and usually the problem is to use past historical data and to predict, and it's embedded that it will go wrong, and by design. If you don't care about the careful data capture and to ensure that it's always representative and so on. But there is another huge bubble of applications of AI where when you use AI for screening or digesting a large amount of data and information, assisting the decisions, and it's, I think, a bit different than putting a human at the end of this chain, but it's helping us in understanding far more data and information when it was possible to do before. And this is I think, where AI excels really, to find emerging patterns, to find, in complex systems again, in complexity science, to find different connections between different variables where you cannot do by your hands and human intelligence. And this is something where I think we should focus on, that this is something where there is a huge added value compared to very automated algorithms where you by design embed the human bias and end up with these not so funny stories. But it's just purely a bad study design in case of hand washing, for instance. Yeah, that's what I want.
But then you still assume that the human writes the initial code, which is nowadays not the case anymore. There are AIs that actually generate code, so you just tell the AI, oh, give me some Python code to create a figure, and then it will give you code. And then you say, nah, give me a prettier figure, and then you will get different code. So it's actually the AI writing the code, running the code, interpreting the output, making this. What will we do if the AI takes over?
But isn't it that the case that before you actually release a product, put it on sale, put it on the market, isn't it the case that you decide who is going to test it?
Yes. So yes, testing is then most
testing.
important.
Who is going to test also? Who are the people who can mostly be affected by this? So, for example, in that case, if you had a diverse workforce, for example, a black person would say, "Well, I want to see if it works with my skin." Do you see what I mean? You know, it's really important that a product is fully tested. I would also very much like to see two things. First, can we think about a sort of kite mark or something that says, okay, this AI, I mean, the EU is doing this with the CE mark, right? The CE mark and says, okay, if a product is ready, it's been tested, it does have, you know, it's transparent and all of that, that can have a CE mark, but this is mostly for like a high risk product, a CE mark that says, yes, okay, this is fit and ready to go. To me, this is really, really important. And the other thing is the redress element, going to the trust thing. If I am somebody who is negatively affected by something, even, you know, if my skin is not recognized, how do I obtain redress? You know, this is really important for trust, because if I can't obtain redress, financial, moral redress for what has been, you know, the way I've been discriminated against, then people are never going to trust these systems.
Yeah, that's right. That's right. And also maybe a slight addition that will also mean that AI shall become a very strategic question and point in overall government and policy-making decisions. So we have to discuss these questions. These are solvable ones, but we have to put in place policies and legislation to have this possibility for redress. But it also means that all the actors here sitting, their institutions have to embrace that we will be discussing these questions in the next 20 years. And our organizations have to adopt some new way of working, way of thinking, and so on and so forth, which leads to change management and how we will do this. It's not an obvious one, but...
We cannot wait for 20 years.
Yeah, I know.
We should do it today, now.
But we will be discussing for 20 years.
What we have been discussing for the past however many years. No one's mentioned Asimov yet, so we won't go back there. But, you know, today was about considerations and recommendations for concrete adoption. We have identified a lot of the challenges. I think it's fair to say we haven't identified the solutions yet. We've maybe tinkered around the edge and come up with some ideas. We have a question or a comment in from Bert Popping asking, are we seeing the same phenomenon with AI as we saw with GMO? While green or food biotech saw low trust, red medical biotech is more accepted. So the question is similar. And Bert's asking, what are the areas where the use of AI might be more acceptable? Is AI-based risk assessment one of them? Marcus, I'd like your thoughts and your perception of that.
Thank you, and thanks to Bert for the question. I think there are some similarities, and they're probably centering around how well can we explain the benefit to people. So self-driving cars have immediate benefit to the person who is tired of driving, and hence the adoption is much easier. We can observe that already. Using AI in aspects that are more personal, like personal health, food safety, or any other health issues, will most likely be much more critical to communicate in a way that people would like, or the consumer would like to accept that. And ultimately, again, it's about trust, right? I mean, we have to trust many authorities or people or knowledgeable, presumably knowledgeable people, because no single person can understand everything in medicine. No single person can understand everything in food safety or food production. And so we ultimately always have to fall back on trust, no matter how much we consider ourselves an expert, because we will not have the data and the knowledge to evaluate every tiny little detail. Now, how we communicate that will be absolutely key. AI will come, AI is there, it's absolutely inevitable. We don't have to fight whether AI will come or not come. It does, and it has been, and it will most certainly also in risk assessment. But we have to, I believe we would do better in adding more efforts to, just to borrow that from Raluca, to testing, and more efforts to talking about what we do to make sure that nobody is left out, that no biases are overlooked or tolerated once they have been observed. that people do think about that. If we use machine learning and AI, we will fail faster at a bigger scale. That's the whole idea of AI, making faster decisions, bigger scale, ever more. And so that will go for failures too. Um, Ivana pointed that out already a few times, and we humans create AI, whether it's the AI that generates code or whether it's the AI that analyzes data and was human programmed. It doesn't really matter. It comes back to humans. So we build in our biases that we would build in anyway, and AI will just magnify and amplify all of that. And the only that that is inevitable. So the only cure, if you want, to that or mitigation mechanism is that we talk and are more explicit and specific about what do we do to overcome that, or at least to try to demonstrate that we're asking these questions during the development and the deployment and the operation of those systems, and that we monitor those systems. And here is how, and here are redress actions. That's again the thing about how to interrogate an AI if the decision was taken. How would an AI explain these, and what do I do if I don't agree? And yes, there are, maybe just a final comment, there are efforts towards cars and manufacturer is held responsible. That does not apply to AI in risk assessment, because these are just computer programs. And preferably they're open source because of transparency. So by extension, then it becomes really hard to say who owns that and who is ultimately responsible for that. And there is no product at the end. There is a decision, thumbs up, thumbs down, a maximum limit, whatever. There's just a piece of paper as the output. And that will pose different questions to liability. Thank you.
Thank you, Marcus. I'm looking at some of the comments coming in. Hubert de Leiker has distinguished between what A is looking at in terms of data. It takes on board not only numerical data, but also alphanumerical or text data as input. He's asked, what are the role of linguists in this process? We're not going to get into that today because I've done events with linguists and they are terrified. But the news isn't all bad. They're going to adapt. Jose Cortinas Abajantes is asking again, what is being discussed is that AI should understand more of the stats principles to help us test the systems, to study design, population to which we want to generalize our conclusions are crucial. Is statistical knowledge not the key to this? And I think this was something that I wanted to come back and to ask you about, but also drawing on Marx's point that we need to communicate about what AI is if we want to gain trust. Would it be better to not call it AI? Would it be better to call it something like a number crunching machine? Because the general population thinks they're really bad at mathematics. So they might be happy to let a computer do that.
So let's call it the improbability drive. And for the people who know the number 42 now understand this joke. So from now on, let's call it different. No, that's not going to work. I like the statistical training there because I think for the next EFSA conference, I think the first session should not be with keynote speakers, but a Python training course or a hardcore mathematics course. Some people started to applaud, but I don't think that most people agree. But it is a solution. So statistics training or AI training or data science training, whatever you call it, I don't care. Training is key. And at universities, we're trying to make data science training part of every curriculum, not only the data science bachelors and masters or the statistical bachelor and master, but also psychology and also medicine, bioinformatics. So data science should be part of any curriculum and any EFSA conference.
Well, I think...
I see some thumbs up there.
Next time. But I think, you know, just to come back to what Akash said at the beginning about school children, I think possibly there's a lot of kids need to start learning what statistics are and how to read them and understand them, never mind even how to generate them. Looking again at some of the questions, Pablo Gomez de Mayora asked this question quite a long while ago, Akash, I think it was aimed at you, asking what are the possibilities of AI in regard of studying complex systems? So processing non-linearity, emergence, spontaneous order, adaptation, feedback loops, etc., etc.
Yeah, I think it's very much about AI. Not only AI, as I said. There are other. There is still a definition problem, what we call an AI and what not. But generally, what I believe, as I said, is that complex systems should be addressed by this very specific field of science, where AI and advanced data analytics are playing a key role in it. So it's not that we could address these questions with usual statistical tool set. And this is where AI should excel, really, in these questions. What are the applications? I mean, there could be a lot. And for a starter, I think complementing the opening statistical course or Python course, I would also add network science to the question, because this is something which I think should be way more taught in schools, in curricula, and in general for everyone. And also coming back to the teaching or education question, I think it's a problem for every country in the world, and we are not going to change this, certainly. But teaching mathematics and statistics in school is not a good process. Currently, it was designed a few decades or hundreds of years ago for very specific tasks, and these are not the ones which we need now. And what we end up is kids who don't like mathematics and are afraid of numbers and data and statistics. And this is something which we are not going to change here, but I think it's a key component in the trust question of the society in general. Yeah, this is a pain currently.
Well, we're going very much back to first principles here. We're not an education conference today. So I'm going to take a question, because I am conscious of time running out as well. Our last question from Aaron O'Sullivan, who's asking the entire panel. The energy cost and sustainability aspects were mentioned at the start, but this wasn't discussed on a deeper basis. Sorry, Aaron, we have only a limited amount of time, but what are the views on how to solve this? Should it be mandatory that all new cloud solutions and AI or machine learning must only use renewable energy sources? Very briefly.
Yeah, I mean, this, to me, this is a key point, because, you know, we all talk about environmental sustainability, and this also, we live in this world where we just say, how can AI make us more sustainable? Well, yes, okay. There are, you know, we can certainly, there's a lot of applications of AI to be more environmentally friendly, but we're not looking enough into sustainable AI systems. I mean, I've got some, you know, as we said at the beginning, so AI runs on infrastructure, on machines, and these consumes energy. And the tech industry is estimated to be responsible for 3.5 or 4% of the global greenhouse gas emissions. So we are talking about something quite big that we need to address. In an article which is available on the UN, the website, I put a five-step roadmap for sustainable AI, with the first point being reducing the environmental footprint and how strategies on how to do that, the impact of data centers and how they have to be more innovative. And for example, countries that are new to the AI space, you know, that they have a great opportunity here, because they can build their data centers in a way that are more efficient from an environmental perspective compared to all the ones that we can have in some of our countries. The other thing is how we deal with e-waste and how we deal with making sure that products can be reused, and also how we challenge this sort of data consumption model that we live on, including the data extractivist model that we rely upon. So that means, for example, how do we reduce the energy of things like video messaging, and does it have to be like on all the time? I mean, we've seen it during the pandemic and even now, how much this is consuming energy. But also, how do we really need to collect all this data as we do now? I mean, there is issues, for example, that we're looking into around synthetic data. Can that help? To what extent? In which fields? Not every field would work. And the other thing, the last bit in here, the fifth step for me, would be around how regulation can help procurement, for example. How can regulation and procurement and really reward organizations that use more efficient and energy saving artificial intelligence? So those are sort of 5 steps, but this is a real important issue. Otherwise, we'll just talk about how AI can help us, but we don't talk about how we can make sustainable artificial intelligence.
briefly, do any of the other panelists want to comment on the sustainability issue?
Maybe just one addition. I completely agree, and this is something which we didn't talk much about. That's the truth. Is maybe adding to the point 4, I believe, is that the reuse of data. So we are generating data in member states, just to connect to the food safety questions. 27 member states collect very similar data, and they are in a way shared through EFSA, but it's still not utilized currently. So if I, as a Hungarian researcher, want to do a research on various data of European countries, it's very hard to access and very hard to reuse this data. And not talking about all these statistical backgrounds, how to reuse the data, what was the original population, where the data were coming from. But still, data sharing, open source data sharing, reuse of data, this is something which could contribute to the sustainability and also could ensure a better life for the data scientists, because there is a lot of data out there and we maybe don't know about, and we then, as Marcus said, it's very expensive to generate new data, but probably there are already data or similar data on a specific issue which we could reuse.
Marcus, your thought on that sustainability question?
I think it is and will become a ever more pressing question as we lean up against the planetary boundaries or press against the planetary boundaries in almost every aspect. Sustainability will become even more on the forefront of every discussions. Now, where we in general have a hard time as a society or societies is to define really the trade-off decision. There's always a trade-off. We need to make compromises. So we can focus only on sustainability, but then we run into trouble elsewhere, like maybe food availability, or we don't have AI because we consider it unsustainable. So what does that mean? So how would we compare the benefits to the costs? We are better at calculating costs, greenhouse gas emission or consequences in that regard, and that's fine. But what scale would we use to compare this to the perceived or actually real benefits, better the real ones? And how much of a benefit would we need to compromise something on sustainability, or how much of a benefit would we forego to not compromise sustainability? I think we have no clear measures. We struggle talking about that as a societies, and I think that will become more of a tenor and more of a topic in certainly future months and years to come. We will have to resolve that. At the current status, it's difficult to have these discussions. Thank you.
I think you're right, Marcus. We've talked sustainability, but of course, in the current geopolitical climate, resilience and sovereignty are also questions, and sufficiency are also big questions that will be answered not necessarily in this room, but will be certainly discussed across this whole event. I want to now relaunch the poll. I know Ilaria had the poll earlier. We're going to launch it again to see if there's been any shift in opinions. A wise man changes his mind, a fool never does. And what's the other one? The best way to indicate that you have a mind is to change it. It's the best evidence that you have a mind. So the same question we are going to ask again, which is, among the following statements about the usage of big data and adoption of AI in risk assessment, you have 4 multiple choice answers there. AIs and humans will seamlessly cooperate in the future. AI and big data are great opportunities to make faster and more accurate risk assessments and generally improve outcomes. AI, technology and big data availability will never be enough to perform reliable and trustworthy risk assessments, and AI in risk assessment is a liability and makes those assessments untrustworthy because it is inherently prone to biases. So we'll let you vote again while I come back to my panel and ask them for a very brief, quick wrap-up question for each of you, just in general, in a minute or less. How optimistic or pessimistic are you that AI is a game changer for risk assessments? We'll leave that. I'm going to let one of the others come back to that. So, Ivana, how optimistic or pessimistic are you?
I'm cautiously optimistic, as is any aspect of life. But I do think that we have a huge opportunity now to get this right. if I bang on often on the risks and the challenges, is not because I do not like this technology, it's the opposite. It's because I like it so much that I want it to work for everyone, and I want the digital dividend to be distributed more fairly compared to how it is now. So focusing on the risks and focusing on the challenges is for me is a very important way so that we are ready to really harness the benefits of this technology. I think for as long as we have smart regulation in place, and I encourage everyone to get involved in, at the moment, of the discussions on the European AI Act. Also understanding the European AI Act is not the universal law of AI. Human rights legislation, non-discrimination law, consumer legislation, liability, data privacy. Actually, privacy is instrumental in artificial intelligence. You can just look at the Future Privacy Forum report on how on AI and algorithmic decision making in GDPR, and get involved into the discussions. That is really important. The way we shape AI now is going to be influencing the future.
Okay, can we get Marcus back? So I get Marcus's very brief 2 or 3 sentences on how optimistic or pessimistic you are, Marcus. Game changer is a big word, but are you cautiously optimistic like Ivana, or are you somewhat more concerned?
Thank you. No, I think, yeah, I'm optimistic. I don't even know. I mean, AI is already here, so it has an air of inevitability to it. It's already there, so I don't need to be optimistic or pessimistic. It will develop. Whether it will not be the AI we know today, there might be different technologies that we home in tomorrow or next year that overcome some of the limitations that we're currently discussing. But I do believe, and I want to be optimistic, that we find ways to not only talk in our echo chambers and reach across the not the aisle, but reach across the dimensions or the disciplines and potentially even countries or regions to come up with some processes and features that would work for most of us in this world, and not just for a specific region, or not just for a specific company, or not just for a specific segment of the industry, or a specific discipline. So hopefully we get out of our echo chambers, and then progress will be made. Thank you.
Akash, optimistic or pessimistic?
That's a good question. I'm optimistic very much on the capabilities, where it can evolve, but it won't happen if we don't discuss these questions, if we don't acquire knowledge in terms of data literacy, we don't share data and expertise, it will not really happen. And at the end of this whole thing, we are still humans, and the big questions of life are value questions. And AI may be conscious in the future, but still it will be one actor discussing these value questions of big life questions. So I'm optimistic, but it's not the only thing in life.
I think the future is already here. Talk to some young people in your groups. They may think completely different about the adoption of AI and might blow up your mind. So I encourage you during lunch to talk to some young people and ask their opinions.
Well, that's a wonderful William Gibson quote. The future's already here, it's not just evenly distributed. So we're going to close that poll, and I will leave it to the chairs to come back and have a look at it. I'd like to thank all our panelists, including Marcus joining remotely, of course, and Ivana, Ranj, and Akos for the great conversation. Thank you, our audience. I'm supposed to wrap up and summarize what we've said, but obviously I am not an AI. I can't possibly do that. I think access to data was talked about as important, trust, the importance of testing, the importance of redress, and always having a human in the mix. I think that's the best summary I can give you. But I will go back and I'll quote Kranzberg's first law as a way of saying goodbye, which is that technology is neither good nor bad, nor is it neutral. So big round of applause for our panelists.
Thank you very much for this very fruitful discussion that we've been witnessing in the last 60 minutes. And then now we have essentially the result from the second vote. And I must say that during this morning, we have at least improved data visualization. So I have to say that what we can notice from these is essentially that there is a shift from the second to the first question compared to the initial results. So essentially we were saying that almost 80% or 70% were believing that artificial intelligence and big data are great opportunities to make faster and more accurate risk assessment and generally improve outcomes in regulatory science. And this is still the perception, but we also have a stronger view that AI and humans will seamlessly cooperate in future risk assessment. So I think this is a great achievement. Also, we can notice that they still recognize that AI technology will never be enough, at least at this stage. Human intervention will still need to be performed to also provide reliable and trustworthy outcome when it comes to risk assessment. So I think this is the result of today, and thank you very much for all the audience contributing to the police station here in person, but also remotely. And with this, I think we are heading towards the end of the session. We saw this morning two very interesting and concrete presentations from Dr. Martins and Marvin and Raluca Crisan on the testing. And then we had us outline this panel discussion, and I'm handing over to my co-chair, Guy, to wrap up on the key take-home messages.
Thank you very much, Ilaria, and again, thank you very much to all the people that have been taking the floor today and also for the questions. Now, I took some notes myself, but I realized that you need some artificial intelligence to go through what I've been writing here. I will nonetheless try to summarize some of the, or to highlight some of the questions that have been raised and that maybe we should pick up and also the organizers should pick up and we should do some further thinking about. In relation to the questions, there was a lot about the quality of the data, and also Marcus mentioned the cost of the data that eventually need to be generated. It's not only about the data, but I think a lot of emphasis has also been put on the bias of the data, the judgment that is in there. We heard about data that have been collected about what I would call the male white from the higher class, and then we heard the anecdote of the racist step, and we need to really avoid that. But I understand then again that artificial intelligence again can help us in avoiding the bias. The use and misuse of data has been mentioned upon quite often. One of the people in the panel mentioned that data in fact are not neutral at all. The question is, do we trust the system despite the fact that we distrust all the systems that we apparently seem to be working with? Lots of questions also about the risk of artificial intelligence and the accountability, the liability, and how we can compare that with the liability of human and human mistakes. A very important question was also raised about can this be used in low and middle income countries, and to what extent can it be used? Also, can it be used across the different sectors? Some people mentioned that in food, for example, food safety, we don't have ontologies and we have 20 years of backlog. So the applicability of the system across the different systems is also a question. And then, yeah, indeed, if we talk about sustainability and at the same time we consume so much of energy and resources, does the application of AI and machine learning, is there an environmental sustainable application, or on the contrary, is it consuming more than it is providing benefit? Then it's not up to me to give recommendations, but I collected some of them through the different interactions and the different presentations. One, of course, is about the validation of the pipelines, the efficacy of the system, the trustfulness. Trust was a word that was coming up again and again. We also need to understand that solutions will not be one fit for all. Solutions often address different stakeholders group, and these stakeholders group need to be well informed, need to be well communicated. We need to be critical about about getting data, and we need to even be more critical in the future and clear about what we are going to use them for. For whom, the for whom part is a very important one. Some were suggesting step by step, but then a kind of an addition was make step by step is probably for the elder people here. If we involve younger people, they are already using it, and they have embraced the technology, and I think it would be a very beneficial item if we include the younger from the onset into the exercises. I've been listening about the CE marking as well, and also with the possibility to redress if systems do not function very well. I heard about the training that we would probably all need about statistics data and how to use them and so on. And then I think it was Marvin in his presentation, and with that I would like to finish. Marvin, I think that at the end of the story you still need to have the human to go through the whole system and to do some other step of validation of the outcome of the system. So I very much appreciate that this is far from comprehensive. I mean, the discussions, the presentations have been so rich that it is impossible to summarize them, but as I said, I did what I could, and I hope it's a good indication also for taking some points together with the organizers later on, and then to address some follow-up activities. So with that, back to you, Ilaria.
Thank you very much, Guy, and I think it was actually a very good take-home messages for the audience today. As you said, a lot of topics have been touched, and they will be probably shared in a closing report for this session. So with that, we are heading towards the end of the session, and first of all, I would like to thank all the audience in person today, but also remotely connected, and allow me to thank also the contributors to the session, so the moderators, the speakers, and the panelists. But first and foremost, let me thank the people behind the scene. Angelo Cafaro, that has been the coordinator for this session, and all the rapporteurs for the monumental work that they've done to make this session so good. And with this, just the final announcement is that there is going to be a post-session virtual lounge for the colleagues that are remotely connected. So this is going to be launched in 10-15 minutes. So I would ask the colleagues that are here in person to leave the room to allow the connection for the virtual lounge. In the virtual lounge, some of the speakers and contributors to the session today will be available for an extra 30 minutes. For further reflection, discussion, and question. And with this, I would like to close the session and wishing you a very good continuation of the conference, which will resume at 2 o'clock. Thank you very much.